So today we're going to continue on with unit circle trig. Yesterday we looked at the quadrantal angles, found the coordinates, and we also looked at what happens if I give you the coordinate, how you can just use that directly. Today we're going to look at three other angles: 30, 45, and 60. The first one we'll focus on is the 45. Okay, our goal here is we want to figure out what is the coordinate for a 45-degree angle. Once we know the coordinate, then this problem is going to be exactly like we did yesterday. Okay, so on your unit circle, 45 degrees is halfway between 0 and 90. And our angle would be right there. Okay, so we don't know the coordinate for 45 degrees yet. Okay, but what I've done is I basically made a triangle, okay, out of that angle, and I copied it over on the right-hand side. So actually that side would stop right about there. And I made a right triangle. So it's a 45, 45, 90 right triangle. How come I can label the hypotenuse as 1? Why do I know that that distance is a 1? Yep?
Because the radius is 1.
Right, we're working on a unit circle. Okay, unit circle has a radius of 1. Unfortunately, the hypotenuse doesn't directly give me the coordinate. What I need to know is the length of the base. That's how far over I go from the origin. And then I need the height of that triangle. Okay. I don't know the base or the height, but what do I know about the base and the height if I compare them to each other in a 45, 45, 90 triangle? Yeah, they're the same. Right? This is an isosceles triangle. It has two angles that are the same. Since I don't know the height or the base, how can I represent it just for now? Oh, Kyle? Sure, yeah, we just represent it as a variable. How many variables am I going to need since the base and the height are the same? Just one. So if the base is x, the height is x. Okay, just picked a variable. Okay, now I need to solve for x. And then I'll know the base and I'll know the height. Okay, what formula could I use here to find the length of x? It's not a formula that I've taught you, but it's something you should know from geometry, dealing with a right triangle and the side lengths. You know the formula that relates all the sides of a right triangle from geometry? Well, Ben, do you think you know it?
Yeah, no, I can't remember. I'm trying to say, but I'm good.
Anyone help him out? Either the name of the formula or what the formula is. Either way.
A squared, B squared, C squared.
Okay, what is that?
Pythagorean theorem.
The Pythagorean Theorem. So I want to use the Pythagorean Theorem on this triangle, filling in what Andrew just said. Okay, so what did you say, Andrew? Can you say it one more time?
A squared plus B squared equals C squared.
Okay. What's A, B, and C? Can you just tell me what's what?
C is the hypotenuse.
Okay, C is always your hypotenuse.
A
Yep.
and B are the legs.
And A and B are the legs. What are the lengths of my legs here?
X.
They're both x. So I'm going to fill in x for my legs. And how long is my hypotenuse?
1.
1. I'm going to fill that in for C. Okay, so I get x squared plus x squared equals 1 squared. Now I have an equation with just one variable. Okay, Lydia, on the left-hand side, I have x squared plus x squared. What does that combine as? Think about it as maybe having 1x squared plus another x squared. How many do you have? 2x squared. Okay, so 2x squared equals 1 squared, which is 1. Okay, Adam, what could I do next to get x by itself? Take a second, think, what do you have to do to get x by itself? What's preventing x from being alone?
Oh, you can divide each side by 2.
Yep, divide each side by 2. So now we have, let me just go up over here. X squared equals a half. So now we know what x squared is, but we want x. So what do I have to do on both sides? Yeah.
Square root.
Yeah, take the square root. Square root, square cancel. When you take the square root of a fraction, the way you can do it is you take the square root of the top and bottom separate.
How come there isn't still 2 with the 1/2, like a squared with the 1/2?
A squared, well, I did out 1 squared. 1 times 1 gave me 1.
Oh, okay.
Yeah, so now I just have 1 and then I divided by 2. So we did out the right-hand side. Okay, in the top, Emily, what's the square root of 1? 1. Yeah. What times itself gives you the radicand? You get 1. Can you simplify the square root of 2? Does the square root of 2 simplify, though? No. So we just have to leave that the way it is. And Shelby, how would I fix that up so we don't have that root in the bottom?
You multiply the top and the bottom by the square root of 2.
Square root of 2 over square root of 2. And what will that give me?
Square root of 2 over 2.
Square root 2 over 2. Okay, now we know what x is. So now we can write our coordinate for 45 degrees. Okay, Amy, how long is the base of that red triangle? Keep in mind, this red triangle is that triangle right there. So when we have this triangle, we go over square root 2 over 2. That's the x. Okay, and Sam, how high up do we have to go?
Square root 2 over 2.
Yeah, it's the same as the base. We go up square root 2 over 2. Okay, so that's my coordinate for 45 degrees. Root 2 over 2, comma, root 2 over 2. Now that we know that, we can use the x and the y value to find anything we want. The sine, the cosine, all 6 trig functions. Bless you. Okay, any question on how we figured out x? Okay, just use the Pythagorean theorem on a 45, 45, 90 right triangle. All right, so now what I want to do is find the 6 trig functions for 45. Okay, so Brandon, what's the first thing you'd have to do if I give you an angle? You need to know the what?
Coordinate.
The coordinate, exactly. First thing I need to write down is the coordinate for 45 degrees. If you forget it, you can go back through all those steps again and figure it out, but it's a lot better to just memorize. Okay? So Brandon, do you remember what the coordinate is for 45 degrees?
The square root of 2 over 2.
Okay.
And square root of 2.
For y as well. All right, so there's your coordinate. Okay, why don't you try that on your own? See if you can figure out the 6 trig functions of 45 degrees, using the same formula as we did yesterday. All right, so we got our coordinate for 45 degrees. Okay, let's start with the sine. Tom, what's the sine?
Square root of 2.
Yeah, which one is it? Since they're the same, we can't really tell the difference, but is it the x or the y? Yep, it's the y. If you made a mistake here, you'd get lucky, it wouldn't matter. Okay, but want to be careful with that. Okay, how about Matt? What's the cosine?
Square root of 2 over 2.
Yeah, it's also root 2 over 2. This time it's the x. Okay, and the tangent. Okay, Olivia, what's the tangent?
1.
1. How can you get that really quick without even doing the work?
Because something divided by itself is just 1.
Great. Tangent is y divided by x. Dividing two things that are the same, you get 1. Okay, so another quick one to find is the cotangent. You flip it, and you get 1. Okay, Max, how do we get the cosecant?
You switch the element. Switch it.
Can you be a little more specific? By switch, you mean flip, got it, and flip which one?
2 on top and square roots on the bottom.
Do you remember the name of the function you're flipping?
Cosecant?
This is the name of this one, but we're flipping that one, which is, just put an E on it, sine, yeah. You're flipping sine, okay? So you flip sine to get cosecant. Flip cosine to get secant. Okay, so we get 2 over root 2. And Sean, what will that simplify to?
Well, when you have to do a 2 to square root over 2 to square root first.
Yeah, you multiply top and bottom by square root 2. So yeah, we can do that. Okay, and that would give me, what would I get in the top?
On the top, you would get 2 times the square root of 2.
Yeah,
And on the
There you
bottom,
go.
you would get just 2.
just 2. And now what's going to happen with the 2's?
You cross out the 2.
Those cancel out. It's all we get is the square root of 2. Okay, Lydia, what about the secant of 45? It's the same thing, right? Because we already had root 2 over 2. We flipped it earlier. So flipping it again, it's going to give us the same thing. Okay, so those are your 6 trig functions for 45 degrees. Any questions on them? All right. So next we're going to move on to the 30s and the 60s. Okay, to do this one, we can't look at a 45, 45, 90. Okay, we need the 30, 60, 90 right triangle. Okay, this is 0. This is 90. Okay, 30 degrees would be about a third of the way towards 90. So what I need to figure out is how long is the base of that triangle and how tall is it? That the base will be my x, the height will be my y. So that's what we need to figure out. Is there anything in that triangle, I've just drawn it a little bit bigger off to the right, that I do already know? Any lengths in that triangle that I can use to, because I got to know something. If I don't know any lengths, then I can't do it. Yep. Yeah, the hypotenuse is 1. Because we're still on a unit circle. What kind of triangle is a 30, 60, 90? Is it isosceles like the last one? Yep, it's a right triangle. This one is a right triangle. And what about in terms of like isosceles or equilateral? Or, this is scaling, which means what? All the sides are different. which means if we want to represent the lengths of these sides, can we use the same variable twice? No. We're not the same anymore. So if we were going to do this, we'd have to pick an x and a y. Problem with doing that is then we're going to have two variables, and we're only going to have one equation. We're not going to be able to solve that. You'd have, using the Pythagorean theorem, you'd have this. Well, that's not solvable. Okay? So we can't use the Pythagorean theorem, at least yet. Okay? Any suggestions what I can do here? This next step is tricky. You have to be extremely clever to think what to do next. Okay, I want to add something to that picture. Kind of down below. Does that give anybody a hint at what I'm going to do? I'm going to somehow use the picture that's already here, but I'm going to add something to it below. Yeah.
You just like flip it.
Yeah, I'm going to flip it. I don't want to flip the 1, though. So take my, let's take the triangle. Let me, is it already grouped? Oh. I'm going to make a copy of it, and then we're going to flip it. I'm going to flip it that way. Okay, I'm just going to keep that triangle there temporarily to help me do something, and then I'm not going to need it. All right, so now we know that side's 1. How about the side that has the negative slope on the bottom here? How long is that side?
1.
That's also 1. And how about the vertical side on the right?
1.
That's also 1. So the key is that vertical side on the right. The whole thing is 1. But it's composed of two congruent triangles. Congruent means that all the sides in one triangle are the same as the other. So what does the height of each individual triangle have to be? A half. And that's the whole reason that I did that. Now I know 2 out of 3 sides in the top triangle. Okay? Any questions on that? Okay, nobody mentioned it, but the reason why all the sides are 1 here is because we just created an equilateral triangle. The angles are 60, 60, and 60. Okay, now we don't need the bottom triangle anymore. Okay, that's all we really need. Okay, now how many sides don't we know? Just 1. Now I want to do the Pythagorean theorem on this triangle, but there's only going to be 1 letter. So we'll do it just like we did before. Okay, Michaela, can you fill in my legs and my hypotenuse and tell me what the Pythagorean theorem will say?
X squared
Mm-hmm.
plus a half squared equals 1 squared.
X squared plus a half squared equals 1 squared. Perfect. Okay, Naisha, what's 1/2 squared? 1/2 times 1/2. That'd be a half plus a half. This is like taking a half of something and then taking a half of that. How much would you have? 1/4. Right? 1/2 times 1/2 is 1/4. Just get rid of that. Okay, now we're going to bring the 1/4 to the other side. So x squared equals, what's 1 minus 1/4? Josh?
No, use a calculator, please.
Sure.
Oh, 3/4.
Oh, yeah, 3/4. Okay, so 1 minus 1/4, that's 3/4. And my last step, Ashley, to get the x by itself,
Use square root it.
take the square root. So square root 3 over square root 4. And Max, what will my final answer be? So we're just about there. We just have to simplify that.
Well,
Well, if I square both sides again, that's going to take me back to the last step. I don't want to have an exponent with the x. So I took the square root to get rid of that exponent. But there's some stuff here that simplifies.
And get the square root out of the denominator.
Yep, but in this case, the square root of 4 comes out to a nice answer, which is
2.
2.
You knew you'd get it.
Okay, so x is the square root of 3 over 2. Now we can write the coordinate for 30 degrees. Okay. What's the length of the base of the triangle? Sarah?
Square root of 3 over 2.
Yep, it's my square root 3 over 2. And now the height of the triangle, that's my 1/2. There's your coordinate for 30 degrees. Okay, now for 60, because 60 was in the same triangle, we don't have to go through and do all the work again. We should be able to just reuse what we already have. And hopefully a little common sense. Okay? 60 degrees would be more up there. This would be our triangle. So it's basically the same triangle, but instead of laying on the long side like it's laying down, now it's standing on its end. So any thought what the coordinate for 60 degrees would be?
1/2.
Yeah, 1/2. Because now it's the shorter side is x. And what about the height?
Square root of 3 over 2.
Right, now the long side is the height. And that's the coordinate for 60. So the only coordinates you need to memorize are 45. That one's easy because they're the same. Root 2 over 2, root 2 over 2. And then your 30, which is root 3 over 2, 1/2. And your 60, which is reversing it, 1/2 root 3 over 2. If you know those three coordinates, you can do any of the quadrants on this circle. Even though we're only focusing on quadrant 1. Quadrant 2, if you had a 30-degree angle over here, would be very easy. If you think of it as a reflection. The numbers are going to stay the same, except you might have a negative in front of one of them. Either the x or the y, or both. Okay, but for today, we'll just stay in quadrant 1. Okay, so first I want to find the 6 trig functions of pi over 6. Get to try that one. See if you can figure out all 6 trig functions for pi over 6. All right, so first thing we can do to figure this out, we got to figure out the coordinate. Okay. What is pi over 6? That's in radians, but how many degrees is that? 30. So now we know we're either dealing with the 1/2 root 3 over 2 or the root 3 over 2 1/2. If you have trouble remembering which way is which, sketch it. Try to make your sketch somewhat to scale. Here's 0. There's 90. 30 would be right there. Okay, so if I sketch my triangle, the shorter side is always the 1/2. Okay? And this time my triangle is laying down flat. So it's laying on the longer side. The longer side is my root 3 over 2. Any question on that? That's how you can remember. Sketch it. The shorter side is always 1/2. The longer side is always root 3 over 2. All right, so now I got my coordinate. About Zach, what's my coordinate for 30 degrees?
Square root of 3 over 2,
Yep. And my y?
1/2.
1/2. Okay, so my sine is 1/2. My cosine is root 3 over 2. My tangent is what I get when I divide these, which is 1 over root 3, okay, because the 2's are going to cancel. And when I fix it, it'll be root 3 over 3. Okay, how many people got those three for sine, cosine, tangent? Okay, good. Okay, my cosecant is going to be 2. What about my secant? Once I fix it and do everything I have to do for the final answer.
2 square roots of 3 over 3.
Perfect. 2 square roots of 3 over 3. And how about my cotangent? Yeah,
Square root of 3.
just the square root of 3. Any questions on how we got these last two? How'd we get it? The cotangent. So you'd start by flipping 3 over root 3. Multiply top and bottom by root 3. That's going to give me 3 root 3 divided by the square root of 9, which is 3. Then your 3's cancel. So it's just the square root of 3. Okay. Any question on 6 trig functions of 30? Okay. Let's try the other one. Try the 6 trig functions of 60. Since the coordinate is very similar to 30, you should expect very similar answers here. Except wherever you had an x before, now you have the y. And wherever you had the y, now you have the x. So you're going to get all the same answers, just switched around. Okay, so give that one a try, and then we'll go over it. Okay, so now we're finding the 6 trig functions of 60. Okay, first thing I do if I can't remember, I know there's a root 3 over 2, and I know it's a 1/2. If I can't remember, make a sketch. Okay, so 60 is going to be closer to 90. So draw my triangle. Now I can see the shorter side. How long is the shorter side? That's always a half. And the longer side?
1.
Well, the hypotenuse, yeah, is 1, but the longer leg, I should say.
Square root of 3 over 2.
Yeah. The base, that's always your x. The height, that's your y. Okay, now we can find all 6 trig functions. How about Iris? What is the sign?
Square root of 3 over 3.
Yep. Okay, how about Sean? What's the cosine?
1/2, right? Just half.
Yep, 1/2. Okay, and the tangent, Andy?
Negative square root of 3.
Yeah, because you're going to have root 3 over 2 divided by 1/2. Your 2's are going to cancel, and it's just square root 3. Okay, very good. Okay, how about the cosecant of 60? Andrew?
2 square roots of 3 over 3. Wait, no. 2 square roots of 3 over 3.
Yes, 2. Well, I made the same mistake. So 2 square root 3 over 3. Okay, my secant. Okay, that one we're not going to have to worry about any roots. Adam, what's my secant?
2.
Yep, just 2. And the last one, cotangent 60. Sarah?
Square root of 3 over 3.
Yep. When you flip it, some people get confused. If you want, just put it over 1. Think of it as a fraction that way. When you flip it, it's going to be 1 over the square root of 3. Multiply top and bottom by square root 3. And you get square root 3 over 3. Okay, so that's how you find your trig functions for angles that are 30, 60, or 45. Okay, any questions on that? Okay, tomorrow there won't be any new coordinates to learn. We're going to use the same ones again, but you will need a calculator as well. Okay, so the homework tonight will be a worksheet and these 5 extra problems. Okay, so you need to copy down those 5, and I'll give you the worksheet right now.